Hello and welcome to High Voltage Engineering. We're talking about a topic, generation of high voltages and currents. In this, we'll be talking about tripping and control of impulse generator. We have seen how the impulse generator is created. Now we need to look at how this impulse generator voltage is controlled. So, in order to have a consistency in sparking, irradiation from an ultraviolet lamp is provided from the bottom of all gaps. The gaps are arranged such that the sparking of one gap results in automatic sparking of the other gaps as the voltage is impressed on the other. To trip the generator at a predetermined time, the spark gaps may be mounted on a movable frame and the gap distance is reduced by moving the movable electrodes closer. So, this is how the control of the sparking is done. One is that so that the sparking in the impulse generator are done automatically. Remember why this sparking is done, in order to change the setup of the capacitor from parallel to series. Now this sparking generator, you need to have a sparking at a simultaneous sparking of all the spark gaps. So in order to facilitate that, an ultraviolet lamp is provided at the bottom of all gaps, so that this ultraviolet radiation creates it boosts the sparking at all the spark gaps. Okay, and again the spark gaps is made, it is on a movable arrangement structure, so that when we require a sparking, these structures are brought together, so the spark gas becomes very close to each other. So this is how we control the sparking of the impulse generator. So this is one of the method of controlled tripping. Okay, so this is a controlled tripping is where we can control the amount of tripping that is in the spark gap. So this, we have this spark gap and we have a secondary spark rod is provided. You can see, so it creates a 3 electrode arrangement. So the first stage of impulse generator is fitted with a 3 electrode grab. So this is, you can see the 3 electrode grab on the circuit, and the central electrode is maintained at a potential between that of the top and bottom electrode with resistors R1 and R2. So you can see with resistors R1 and R2, okay, the electrode in the middle, okay, the electrode in the middle is can be brought in a voltage that is between the top and the bottom electrodes. Tripping is initiated by applying a pulse of thyrotron G by closing the switch S. So we have a thyrotron that creates a pulse by closing of the switch of S. You can see the switch S is being provided. The capacitor C produces an exponentially decaying pulse of positive polarity. So when we have the pulse is being created with the closing of the switch, the capacitor is charged to a positive polarity. Okay, the pulse goes and initiates the oscilloscope time base. The thyrotron conducts on receiving the pulse from the switch S and produces a negative pulse through a capacitance C1 at the central electrode of the 3 electron grab. So with the generation of the pulses, the generation of the pulse on the capacitor C, capacitor C1 produces a negative pulse on the electron on the central electrode. Hence the voltage between the central electrode and the top electrode of the 3 electrode gap goes to above its sparking potential, and thus the gap conducts. Okay, so what is the basic thing is that we can control when the spark will occur by producing giving an external electrode and then creating a negative potential on the external electrode to facilitate the sparking. Basically, it is nothing but that. So, hence the voltage between the central electrode and the top electrode of the 3 electrode gap goes above the sparking potential and the sparking conducts. The time lag required for the thyratron firing and breakdown of the 3 electrode gaps ensures the sweep circuit of the oscilloscope ensures that the sweep circuit of the oscilloscope begins before the start of the impulse generator voltage. So, you have to take care of the thyratron time lag also. Okay, so before you start of the voltage, so you have to keep that amount of time lag in mind to to take care of the lag in the thyratron. Okay, the resistance are to ensure decoupling of the voltage oscillation produced at the spark gap entering the oscilloscope through common trip circuit. So, this is one more last topic is called the thyratron gap. So, we have seen the control 3 electrode system. This is much more specified, much more better. So, the 3 electrode gap requires larger space and an elaborate construction. Nowadays, a thyratron is used and requires much smaller voltage operation compared to the 3 electron gap. So, the thyratron is the trigatron is shown on the right hand side. So, the trigatron gap consists of a high voltage spherical electrode of suitable size and earth main electrode of spherical shape and the trigger electrode through the main electrode. So, you can see there are 3 different electrodes being present there. The trigger electrode is a metal rod with an annular clearance of about 1 millimeter fitted into the main electrode through bushing. Okay. Tripping of the impulse generator is affected by a trip pulse which produces a spark between the trigger electrode and the earth sphere. Due to space charge effect and distortion of the field in the main gap, spark over of the main gap occurs. The thyratron gap is polarity sensitive and proper polarity pulse should be applied to correct the operation. So, the thyratron gap is a newer gap that control the sparking. So, previously the 3 gaps were used, 3 electrode system was used. Now, thyratron is a much more compact form. So, this is the end of this chapter. Thank you so much.